Hi. So in this video we are going to learn how to recognize what's a good leaving group and what's not. So in general, a good leaving group is something which can very well stabilize a negative charge. Okay, and so that means that good leaving groups are generally conjugate bases of strong acids, and strong acids, can recall, those are things which have pKa is lower than 0. So you're going to make a table here, and on the left we're going to write down some strong acids. On the left you're going to write down the conjugate bases or the leaving groups. Okay, so one of the strongest acids you have seen before is HI. Okay, HI has a pKa of -11, a really strong acid. Then another one would be HBr, is a little bit less acidic, pKa is still -9. HCl, hydrochloric acid, pKa -7. And then something like paratoluene sulfonic acid, which has a pKa of -3. You see, paratoluene sulfonic acid, if you deprotonate it, you will get, if you make the conjugate base of it, it gets a delocalized, resonance stabilized anion. This is why paratoluene sulfonic acid is a strong acid. It's kind of like sulfuric acid. Another strong acid is H3O+, right, hydronium ion. pKa there is -2. So these are all strong acids. And of course, the strongest acids are on top here with the most negative pKa values. So now here on the right, I'm now writing down the conjugate bases of all these acids. And so that means these are now all good at stabilizing a negative charge, either because of resonance or because you have highly electronegative elements. And that means all of these things are good leaving groups. The most stable bases are on top, and so those are the best leaving groups. So I- is one of the very best leaving groups. Something like a tosylate conjugate, the conjugate base of paratoluene sulfonic acid is also a good leaving group. Something like water, which is the conjugate base of hydronium, is also a good leaving group. So I'd like to encourage you to look at table 7.1 for more examples of this kind. And finally, the thing I would like to note is, what about HF? HF is not a strong acid because the pKa of HF is 3. And this means F- so fluoride is actually not a good leaving group. Okay, thank you for watching. We'll see many leaving groups here in chapter 7.